So now you do have a few try it on your owns. What I would suggest is you actually do try it on your own, and then check with the written out notes to see if you got the same answers. They do have the work written out. The only way you can get better at these is if you continue practicing them. So one I know might be a little difficulty is going to be 4. So I will actually walk through this one with you. We have a 2/3 here on the left. So those are the lowest, and you have a fraction, you can't flip anything. So that's the lowest I can get. You can have a 2 on top and a 3 on the bottom. On the right, you have a 27/8. Well, yeah, that's a problem. 27, well, we know that is a 3 cubed, and an 8 is a 2 cubed. So we know we would have to do something about moving those, because we can't have a 2 on the top over here and a 3 on the top on the right, and a 3 on the bottom on the left, and a 2 on the bottom on the right. So what we're going to do is we're going to rewrite our 27/8, and you can do it all in one step, or you can do it in a couple different steps. It does not matter, whatever makes you feel better. Let's just go ahead and flip the 8/27. So that's going to make this 8/27, but we have a -1 on the inside, because each of those would be flipped. And then you still have your x minus 4 on the outside. So you can either do it like this, or actually, I think it might be a little bit easier if you rewrite this as a 3 to the third and 2 to the third first. Yeah, let's just do that instead. I hate to confuse you too much, like I probably just did, so we won't do that. So let's just rewrite these as a 3 cubed on top and a 2 cubed on the bottom. Now, what we want to do is we want to flip each of those. So since they are both to a third, we can flip those, a third power. We can flip those, and it's actually going to end up just becoming a 2/3, but each of those to the third, and we flipped it, so that means we're going to make that to the -3. And then on the outside, we still have this x minus 4. I know, lots of parentheses, but we had to separate some things. And if you notice now, you have a 2/3 here and a 2/3 here. So we can actually now simplify and say we have a 5x plus 1 on the left. And then on the right, you have a -3 times x minus 4. So what we had to do is we had to do a little bit of work here with the fraction, but hopefully this helps out a little bit. So on the right, you get -3x plus 12. Negative times negative is positive. And we're going to add 3x to both sides. Add 3x. And so that cancels that. Then we're also going to subtract 1. Subtract 1. So down. And you end up with, on the left, you have an 8x on the left. Equals on the right, you have an 11. And if you divide both sides by 8, you would get 11/8. So another ugly answer, but that's okay. We don't live in a perfect world. So here we go. So I would suggest try your owns, and then move on to example 2, which is what we're going to do right now. So here we have to write an exponential function. In order to use these points to write an exponential function, we have to use points to write an exponential function of the form y equals a times b to the x. So now this a right here, you have two variables to find. You have an a and you have to find a b. Well, the good news is your a is whatever is attached to your 0. So you should have a 0 comma something as one of your points for every single one of these problems. So your a in this case then is a is equal to 3. So for number 1, it says substitute one ordered pair to solve for a. We actually don't have to do that. What we can do is we can just say for number 1 here is a is equal to 3. So what we do for the second step then is we need to plug our second ordered pair in to solve for b. So we're going to use this equation here where we have y equals a times b to the power of x. And our other ordered pair, this is an x comma y. So you have a 0 comma a here, and then you have an x comma y as your other term. So we're going to go ahead and solve this, or plug our values in. We know for y, we can plug in a 15. So we're going to say 15 is equal to, now our a is a 3 from up here, so 3 times. Now your b we do not know, but your x we know is a 1. So what we have is the equation 15 is equal to 3 times b. So if you divide by 3 on both sides, you're going to end up getting b is equal to 5. So now that you have your a, you have your b, you can actually write your final equation. And your final function then is just going to be y equals, we're following this form right here. Your a is 3, so you'd say 3 times 5 to the power of x. So that's one way you may write it. Another way you may see it written is 3 and then parentheses 5x. One way you will never see it written is like this. How about no? You can't multiply this 3 times 5 because they don't have the same exponent. This has an exponent of a 1. So you cannot multiply these together. Those are separate.